Welcome back. Our topic today is tabular data. Now, we're going to use a lot of left, right, midpoint, and trapezoidal Riemann sums today, so this will kind of sum it all up. Now, the tabular part is a pretty common theme, and it's almost guaranteed to be one of our free response questions. So, we'll go ahead and read the description, and we'll answer a few questions about each one here. So, a school carnival sold raffle tickets as a fundraiser between noon, so that's when time is 0, and 8 p.m. to equals 8. The number of raffle tickets sold t hours after noon is modeled by a differential function r for 0 is less than t is less than 8. Our double prime of t is less than 0. So hopefully you're thinking right away, that's telling you double prime, we're thinking concavity, less than 0, negative, concave down. Values of r of t, and there's our units, hundreds of tickets. Remember we talked about it's all about the units. At various times t are shown in the table. Okay, so part A has two parts. First of all, it says, use the data from the table to approximate r prime of 7, and I'll read the other half later. Well, r prime is clearly telling me to take the derivative at 7. Now, you'll notice 7's not on my table in hours, but I do know it falls between 6 and 8. So we've seen this before. We're just going to, we want the derivative, so we're going to use the slope formula. So I'm going to say r of 8 minus r of 6 all over, let me scroll up a little, 8 minus 6. Alright, so I'm just, to get 7, I'm doing the slope between 6 and 8. So r prime of 7, r of 8 is 11, minus r of 6 is 10, all over 2. I'd get 1/2. Now, we're not going to get any credit until we put some units on there. And, I called the units dummy proof before, and I'm not trying to insult anyone. It's just really hard to screw up. You're just going to read the table. So what I mean by that is I had 11 minus 10. So find 11 and 10 on your table. And go and read the units. It says hundreds of tickets. So that's what I'm going to write down for my units. So I've got 1 over 2, hundreds of tickets. Now I'm dividing, so I'm going to use the word per, and I'm dividing by, and I'm just going to scroll back up here. Notice I divided by the 8 minus 6, and the 8 and 6 are on the line that says hours. So it's hundreds of tickets per hour. Part 2 here says explain the meaning, which we're about to, and show the computation that leads to your answers. So all I have is my units right now, so I need to explain just a little further. Now, since I got a positive number, I'm going to say r prime of 7 indicates ticket sales are increasing at a rate of 1 over 2 hundreds of tickets per hour. Now let's talk about what's important. Notice I'm stating exactly what they wanted. R prime of 7 indicates ticket sales are increasing. How did I know they're increasing? Well, you took a derivative and it turned out to be a what type of number? Well, positive. So that's implying that the ticket sales are increasing at a rate, okay, and underline that word rate. Because you took a derivative, your sentence must include the word rate. And here's what I just found. At 1/2 hundreds of tickets per hour. All right, part B. Use a trapezoidal sum, so let's underline that there, with 4 subintervals, so they'll tell you how to break it up, given by the table to approximate 0 to 8 of r of t dt. And then we'll read further there. So I'm going to start by saying 0 to 8 of r of t dt. Now, a couple things to be careful about. First of all, a lot of times they're a little sneaky. Really pay attention to the bounds. You don't always use the entire table. In this case, it does go from 0 to 8, but many times we'll only have you use a piece of the table. So watch carefully. Second of all, here's where it gets exciting. You have to break this table up into 4 equal kind of brackets. Now, I know it's 4 because it says 4 subintervals, And I don't mean the bases have to be the same, just your brackets have to be the same size. So for example, here to here, that's 1. And then I'm just going to use a different color. And say from here to here, here to here, and lastly this section. So notice the bases aren't the same size. 0 to 2 has a base of 2, and 2 to 5 has a base of 3. I'm not saying that has to be equal. I'm saying your boxes have to be the same. So I'm using 2 boxes, 2 boxes, 2 boxes, 2 boxes. That's what you're looking for to be the same. So with that in mind, I have to write, it's a trapezoidal, so I'm going to start with my formula. 1/2 base height 1 plus height 2. And now, just because we said the bases aren't the same, I'm not going to pull out a GCF of the base. I am, however, going to pull out the 1/2 from every term. Alright, so this first section is going to represent trapezoid 1. So I'm going to use my blue here. The base, of course, is the bottom. This is like your x and this is your y. The base is your x value. So my base between 0 and 2 is 2. And now I have to add my two heights together. Well, basically it's the height at 0, which is my y value at 0, so that's 0, plus my height at 2, which is 5. And now I'm going to add my second trapezoid. So this time it has a base from 2 to 5, so I would say my base is 3. My height on the left is 5, and the height on the right side of my trapezoid is 9. Plus, my green guy here has a base from 5 to 6, so it has a base of 1. Its height on the left is 9, height on the right is 10. And lastly, my purple one has a base of 2. I'll try to squeeze it in here. On the left side, a height of 10, and on the right side, a height of 11. So I am going to squeeze in 10 plus 11. Okay, now I'm just going to do some simple math and hopefully get the correct answer here. So I've got my 1/2, I've got a 10, 42, 19, and 42. Add those up, and I believe that's 113 times my 1/2. So I would say I have 113 over 2. All right, so it said use the trapezoidal sum to approximate that answer. So that's what that's giving me. Now, the second part of the question says, does this approximation overestimate or underestimate the actual value? Give a reason for your answer. And now, the trapezoid was the only special one that we talked about that concavity actually matters on. So if I go back, I believe the original problem said that we were, oops, now I lost it all. I believe the original problem said f double prime was less than 0, implying that we're concave down. So I'm just going to verify it by drawing a picture. So that's concave down and increasing, and then concave down and decreasing. Would look like this. And I'm going to make one big trapezoid. Just change my color here. Say I go up here and up here. That's definitely an under. Connected here, that's definitely an under. So I'm going to say this represents an under approximation. And I know that because r double prime of t was less than 0, implying that r is concave down. All right, next part. This time it says use a right Riemann sum with 4 subintervals to approximate 1/8 0 to 8. Okay, so there's a little more to this one. Notice they have the 1/8 out front. I'll let you think about what that means for a moment. We did talk about that last week. And let's go ahead and set up a right Riemann sum, 4 subintervals. So I'm going to break it up into the same amounts again. 0 to 2, that's 2 squares, another 2, another 2, and another 2. Remember, the bases are not the same. They're just 2 equals 2 squares together. All right, so this time, when it says right-hand Riemann sum, remember when we drew the picture out? Did we go up on the left or up on the right? Well, it should be obvious. It's really just in the word. If it's a right-hand Riemann sum, you care about the right-hand side. So this time I'm saying area equals base times height. And every one looks like it has a different base. So I'm going to start with my first section. The base here from, the base here from 0 to 2 is 2. And I care about the height on the right. So if I look in this section, the height on the right is 5. Plus, my next section goes from 2 to 5. That means it has a base of 3. and its two numbers are 5 and 9, but the number on the right is the 9. Plus, the next section goes from 5 to 6, so that has a base of 1. And its two numbers are 9 and 10. The number on the right, of course, is the 10. And the last section has a base of 2, 6 to 8. And its number on the right, 10 and 11, is going to be the 11. So again, notice even in the picture, I'm not using the left side, I'm ending on the right side. And now we'll just kind of go through. Again, be careful, we have this 1/8 out front of all this junk, and that's coming from the initial problem there. So just go ahead and calculate your math. So I've got my 1/8, that looks like 10 plus 27 plus 10 plus 22. It's 69 over 8. Alright, so there is my approximated value. Part B, it's still on the screen at the top here. Using correct units, explain this guy's meaning in terms of the number of raffle tickets sold. Alright, so we'll just start off by this 1/8, 0 to 8 of r of t dt. Now, hopefully you've guessed it. When you see that 1/b minus a out front, is 1/8, that represents the average. Like average value. That represents the average number of raffle tickets sold in hundreds of tickets from t equals 0 to t equals 8. Okay, now I feel like I have to explain that just a little more. My guess is some of you are a little concerned about the units, because notice you integrated r of t. If you integrated hundreds of tickets, your answer should still not be hundreds of tickets. Or should it? So, the only reason I'm keeping the same amount of same units here is because I'm actually just finding its average. Okay, think about this. If I asked you the average number of shirts in your closet, you would tell me, I don't know, 10 shirts. You wouldn't say 10 shirts per minute, 10 shirts per hour. You would just say what you actually have. So when I'm finding the average of the hundreds of tickets, I'm still going to have hundreds of tickets. So when you're finding the average, okay, it's important that you keep the units. Because again, you're just averaging what you have. Okay, we're only going to do one more problem, but again, it might have a part A or B, maybe even a C here. So it says, during the time interval 0 to 12 hours, water is pumped into a swimming pool at a rate of P of t cubic feet per hour. Okay, and I can't stress, underline those units. All of these questions are about the units. The table below gives values of P of t, a strictly monotonic differentiable function for selected values of t. So part A, using correct units, just explain the meaning of this integral and this integral in terms of water in the swimming pool. Now hopefully you understand they look different, and this 1/12 is jumping out at you as the word average. So go ahead and try to write 2 sentences and then take a minute and compare them to mine. So check out what I wrote. 0 to 12 of P of t dt indicates the change in the amount of water in the swimming pool in cubic feet from t equals 0 to t equals 12. So again, I'm stressing a few things. I'm talking about change. If you wanted to say net change or displacement, that's fine too. In the amount of water, so I'm relating it to the problem, in cubic feet, there's my units, and here are my bounds. And I could actually say hours. The second integral, the 1/12, indicates the average, okay, the average rate at which water is pumped into the swimming pool in cubic feet per hour from t equals 0 to t equals 12. Now, I'm averaging P of t, and that's why I said the average rate that water is being pumped into the swimming pool. This is just describing P of t. And notice when I use the average, I'm keeping the original units. So cubic feet per hour. I'm just averaging what I have. All right, part B. This time, use a midpoint Riemann sum. Whoopsie. with 3 subintervals of equal length from 0 to 12. So we notice we are using the whole thing. Now you've just got to take your time and break it up into 3 equal sections. So again, I'm using the x values or t values in this case to do that. So take a minute and just make sure you can break them up. If I tried to go 0 to 2 and 2 to 4 and 4 to 6, well that's 3 sections, but that does not get me from 0 to 12. So that would not work. Oops, what am I doing? Stop it. Oh boy. Alright, so I'm going to try it again. I'm going to go from 0 to 4, and then from 4 to 8, and 8 to 12. And I think that will work. That is 3 equal sections. And notice these two are going to touch at one point. I'm using the 4 for both this one here and this one here. And I'm using the 8 twice. Okay, so that's legal. Alright, and this time we want a midpoint Riemann sum, and that midpoint Riemann sum is just the area of a rectangle. Alright, so I need the base of each section. So this first one goes from 0 to 4. So that has a base of 4. And the height, now remember it's midpoint, you want the height in the middle. So if I have 3 numbers, 0, 2, and 4, 2 is in the middle, and I want its height. So I'm going to be using 12. Plus, okay, my next section went from 4 to 8. That has a base of 4. And I want the height in the middle. So from 4 to 8, 6 is in the middle, and its corresponding height is 25. Plus, last section here, 8 to 12. That's a base of 4. Pick the height in the middle. Height at 10 is 50. Calculate your areas here, and we've got our answer. So I've got, what is that, 48 plus 100 plus, whoops, probably 200. Looks like a total of 348 cubic feet. And again, how do I know cubic feet? Well, I integrated P of t, which will take off the per hour, so I got my cubic feet. All right, last question for the night. It says C, using a left Riemann sum this time, with 6 subintervals. So they're changing that up on us, of equal length, to approximate 1 over 12, and again, hopefully that sticks out as that word, average. Show the computations that lead to your answer. Then we'll hit the second part. All right, so my first goal is to break it up into 6 sections. And again, the bases don't have to be the same length, just 6 kind of equal brackets. So if I go 0 to 2, and then I'm going to do this section, and then that section, that one, and that one. That looks like a total of 6. All right, so left Riemann sum, just talking a nice easy rectangle, base and height. So if I look at my first section from 0 to 2, that has a base of 2. Now remember, a left Riemann sum, out of the 2 numbers, you're picking the one on the left. So the left number would be 0, and its height would be 0. Add on to that. Okay, the next one is this, 2 and 4. Its base is also 2. And I want the height on the left. So out of 2 and 4, 2 would be on the left. That has a height of 12. Plus the next section is 4 to 6. That happens to have a base of 2. Height on the left out of a 4 and 6 would be the 4. This would be the left side. This would be the right side. Height is 20. I'm going to keep adding on here. 6 to 8 would be a base of 2. And 25. Hopefully you're starting to see the pattern there. 8 to 10 is a base of 2. The height's 30. And 10 to 12 is a base of 2, and the height is 50. And then we'll just carefully add up all of those pieces. That was a 0 plus 12 plus 20, 25, 30, 50, that's if I pull out the height of 2. So I kind of did that in my head backwards. I pulled out the GCF, and so basically I just factored all those out. I'm going to add those together. That looks like a 137. Now if I scroll back up here, I think I had that average value. So don't forget, you also have this 1/12 out front. So in front I also have a 1/12, so that's going to actually get me a 1/6 times this answer for a 137 over 6. Now since I integrated, I lost my per hour, but since I'm finding its average, I'm putting it back on, so to speak. So this is my cubic feet per hour because of that average. Okay, lastly, the question part B there wanted to know is, our evaluation going to be an under or over approximation? Now, if you look back at your table, you can see that the y values are getting larger. So that's implying that the function is strictly increasing. So I drew two increasing functions, one that's concave up and one that's concave down. And then I drew in a left rectangle, and we made a note in the other video to make these as large as you can. And you can see in either function that we have an under approximation. And again, that is because our function p of t is strictly increasing. So hopefully you've got a little bit better idea about the Riemann sums with tabular data, and we look forward to a lot of practice tomorrow. Have a great night.